We are so glad you are all here. Thank you all so much for coming. I'm going to keep an eye on this as we kind of get started. Welcome to the November meeting of the Salt Lake City R user group. My name is Julia Silge. I'm one of the organizers of the group. Andrew is here as well, who is one of our organizers. I don't think I saw Mark. Uh, Mark maybe could not make it today, but we are the R user group in Salt Lake City, Utah. I know that since we've moved to online meetings, we've had people from a lot of different places come, which is really exciting. We're really glad that you're here and able to join us. I'm going to do a couple of announcements before we get started with this month's talk. Next month, in December, in early December, we are having a meeting. We often take some time off around the holidays, but we are having a meeting in early December. So this is actually the meeting from September that was scheduled in September, and we had to cancel because of all the power outages that we had during the really like intense windstorms and whatnot. So this is Emil V. Felt, who lives in LA and is doing, he's giving a talk in early December on broadly about defaults that we use in our software and how paying attention or not paying attention to defaults can impact our results, and more specifically about the use of stop words in natural language processing. So I think that's going to be a great talk. We are going to take January off. So that'll be our time off for the holidays this year. And then in February, we are going to do our lightning talk annual session. So we've done this the past couple of years in either January or February, and it's always a really fun session. And so what we do during this lightning talk session is we have 5 or 6 or 7 folks from our community come and give like talks that are 5 to 7 minutes long, and that are really like narrow in scope, don't have to be like super duper polished. Tell us a little bit about like something you've been working on, a new package that you learned how to use, something interesting that you learn in the course of your work, like something about how you use R. So I'm going to drop the link here for signing up for lightning talks. We've had quite a lot of changes in our group since the last time we did lightning talks, what with moving online. So this is going to be an online event, an online meeting in February. And given the changes in our the makeup of our group, we were thinking that the best way to handle this would be that it is something that is open to folks who come to our group, but we're gonna use as one of the in past years we haven't had trouble with like too many people signing up to give lightning talks, but if we have trouble with too many people signing up for like the time that we have, we are going to use as one of the considerations whether somebody is part of our like local community, like whether somebody like lives or works for a company that is here for us and locally in Salt Lake City in Utah. So that will be just part of like, if we end up having to make some sort of kind of hard choice, that will be what we'll do. So if we really do want to hear from all of you who are part of our part of our community here together. So you can reach out to me or to Andrew or to Mark if you have any questions about that. We already have 2 people signed up who have really interesting topics. So that's going to be a really great session in February. It's always a lot of fun to hear lots of short, really interesting talks. All right, so today we also have a really great, interesting talk. So our speaker today is Gabriella Smith. And so Gabriella is a data scientist at Intermountain Healthcare, which is one of our like our big health a big health nonprofit organization here in our or in our region. And Gabriella is going to be talking about combining R together with Python using reticulate. So Gabriella, if you want to get started and share your screen and whatnot, we are really glad to have you talking about this really important
Yeah,
topic.
sounds great. Yeah, thanks, Julia and Mark and Andrew for having me. I'm very excited to talk about this. Reticulate definitely holds a special place in my heart, something I feel passionate about. So I come from an applied and computational mathematics background. So when I first started coding, I first used Python to code, and Intermountain, when I joined the data science team, it's full of a lot of statisticians who code in R. So a lot of our processes are designed for R. So, I was very excited to use Reticulate to kind of combine the programming knowledge that I had with the functionality of R. So that's just going to be what I'm talking about today. So reticulate is actually a type of Python from Asia. It's known to be the largest Python in Asia, and it's known for its dark patterned skin and very like camouflaged skin. So essentially the writers of this package were trying to camouflage something very large and complex inside of R. So it's a way that we can use our Python functions in our, well, any type of Python scripts really. So a lot of times we're, as data scientists or as statisticians, we're faced with the challenge of choosing between these two programming languages, choosing between using Python and R. And R is very good at statistical modeling. It's what a lot of us like to use for visualizations and for the interactive properties that the visualizations can have, whether it be an R Markdown or a Shiny app. It also has a very strong community. There's 16,000 packages and counting. And so, there's definitely a lot of really great functionality that comes with R. But, on the other hand, you have a Python, which is a very strong programming language. It's used a lot for software engineering and for web development. It's also used to make automated testing work a little better. It's used for web scraping. It's used for API calls, and so we want to be able to have the ability to leverage the power of Python and leverage that very complex functionality within something a little more simple like R. And simple meaning like the way that the user can interact with it is a little bit easier and a little bit broad because we have our studio, because we have that environment. It makes everything a lot easier to use, and it's definitely like great that we are able to combine those two properties of the languages. So there's a lot of things you can do with Reticulate. You can run Python scripts in it. You can run Python functions in it. You can use Python dictionaries. So I think that's actually really a great power of Python is the dictionary object. And so if you ever miss using that object, you can now use it in R. And so there's also ways to convert between those two objects. So I'm just going to run through some code and just go through some examples through it. And if you have any questions, please feel free to ask that in the chat or stop me along the way, and I'd be happy to answer those questions. So the first thing that we would do is actually load Reticulate into our studio environment. I'm also going to be using Plotly, so I'm going to load that as well. And essentially, to use Reticulate, we need to tell R where to look for our Python library. So we point it to wherever it's installed on our desktop or on our servers. So this is actually kind of cool because, if we have, if we're using Anaconda 2 still, or if we have a Python library that's configured a certain way, we can tell R to point to that specific library. So it's very easy to switch between versions if you prefer a certain version of Python, over a different version. And so there's a lot of built-in functions here. So py, dict, py discover. So there's a lot of functions that already come pre-built with this package. And there's also a lot of functions that we can add to it to make it even more useful for what we're trying to do. So the first thing that we are going to do is just run a simple string. We're going to say, let's print hello Salt Lake City. And we can see that it's printed down here in our console. So although this looks a lot like R, this is Python code that we're asking to run in an R environment. So you can just run any type of Python code here. Like if you're familiar with Python syntax, this is how you would set up a Python dictionary. So we'd use these brackets and then create a key as well as a value, and you would do that in more of a list format. So if we wanted to run this string, we're going to create the variable dict1, where we have a key of A and B, and then two values of 1 and 2. And so to call, you'd notice that we have created this dictionary, but the dictionary is not yet visible in our environment, as we see on the right-hand side, but it's still in our Python environment in the background. So we would call that environment using this py and call function, and we'd call our variable dict1.
So I think this is relevant even before we get much further than this. There's a question about it. So I think all of us who have used Python have probably run into like pain around like different versions of Python on the same computer, like virtual environments. So you pointed to one at the very top there. How do you manage virtual environments while you use Reticulate? Or like, do you do it outside of RStudio? Do you set something up separately? Using Anaconda or something like that. Like how do you like to do it? What's recommended practices? Is it painful? Like how does this tend to go?
It's always a little bit painful to manage environments in general, but so you can manage your Anaconda environment through Python or R, which is really nice. I'm going to go down a little further and show how we can load modules into R itself. But I think for the most part, if you're more comfortable with Python, you would want to do that in an Anaconda environment, and you'd want to install your packages and set up everything there, whether that be through conda install or pip install or whatever you're most comfortable with. Does that answer your question? Yeah, okay. Right, sorry. So we can call different Python objects that we have. We can also interact with these Python objects. So if I was going to set a variable x to be equal to 100, we can see that it would come out right here. Our Py environment x is 100. But we can also set a new variable. So we can interact with it. This is just using our syntax. And now we have our y value, which is 200. So a lot of times Reticulate is very good at converting between the two languages. So there are a lot of things that make this very automatic and very seamless. So you don't have to do a lot of this conversion work.
So someone noticed how that object then popped up into your R environment. You could see it. Is there right now any way to kind of have that sort of, observability into the Python environment? Like what's in memory?
Yes, there is. Yeah. So when we start using our Python environment and we start sourcing different functions, those different see, I'll skip ahead to the code that I have.
Everyone's
So if
like,
we
what are
source,
you doing?
if we source a script specifically, and we start to call those Python environments specifically, then those environmental variables will start to pop up. So we see like this X variable has popped up that we've called just by starting to source it. So there's still some nuances with the package where you have to be very kind of specific and diligent about the things you're calling, but it does pop up. I think that's just part of the workings of trying to use these two languages that we're still trying to work out. So you can see that, you know, dict1 is now in our environment as well as X. Right, so just more on Python dictionaries, because I love Python dictionaries. So we can actually create a Python dictionary directly using this py_dic function, and we can give it actually an R list of keys as well as an R list of values. So instead of like how we're doing it here, where we're setting it up the Pythonic way, we can come down here and say, let's set it up how we would set up an object in R instead. So once we view that and we run it like a Python object, now we can see this output looks like how you would see it in a Python notebook, in a Python environment. So we can see now we have the bracket and the list, and it looks a lot like what we were seeing before when we were running this string here. And so we would call it similarly like how we would call it in R. So we would use the brackets and we would call the key itself to get that specific value from the dictionary. We can also call it using the function, which is a $sign here, trying to convert back to R and get that value as well. And then, you know, we do have the ability to convert this dictionary back into an R object. So in R, a dictionary would be similar to a named list. So if we would try to convert any kind of Python dictionary back to it, we can see we would come in with this named list object instead of a dictionary. We can also use Python modules directly in this R space. So I'm going to be using the pandas module. I'm sure you're all familiar with it. You know, essentially it's the data wrangling tool for Python. So before you would use a module, you'd want to install it specifically into your R environment. And so this installation, it's similar with R packages. It would only happen once when you're first using it, or if you needed to do any updates to the module. So you would install it using this conda_install function. And then you would have a string of the modules that you would like to install, like either pandas or NumPy or scikit-learn, whatever you would do. So after you install it, you can then import it. And you know, in Python, we would say from pandas or import pandas as PD. Right, so that way when we call this pandas function, we would be calling this the pseudonym that we made for this module instead. So we can do the same thing where we'd say PD equals the import pandas module. So once we imported that, we would see this module come over here in our R environment. And then we can call it, and we can call the functions that it has. So we can read in a CSV. So this is the Irish data set. So you can read in that CSV, and then we can use pandas functions on these data frames. So pandas has a .describe function, which is essentially the same as a summary table in R. So it would give us just like a summary view of our data frame. So when we bring in data through pandas, R is actually going to store that as a pandas data frame. So there's some functionality, like R functionality won't work directly with a pandas data frame. So if we try to take the sum of a certain column, for example, the sepal length, we find that, it doesn't know what to do with this type of data frame. But what we can do is still use the Python functions on this data frame. So we would say, let's look at the sepal length column, and then we can take the sum function. So this is kind of how you would call a function in Python. It normally comes after the object. In R, we would wrap the function around the object, and we would get a value for that. Now, if you're much more comfortable coding in R completely, we can convert that pandas data frame directly into an R data frame. And so it's actually the same function that we'd use to convert a dictionary. So reticulate is very good at recognizing the object type and being able to convert it. So without us specifically needing to say, convert this pandas data frame into an R data frame, we can just say pi to R iris, and now we can look back at our new data frame, and it's an R data frame again, and we can run R functions on it again. Any other questions so far before I move on to
Not super relevant to exactly what you're doing. I think there's some like bigger picture questions about like web development frameworks and like Dask and or
oh, okay.
But that's probably, we can do that more at the end, I think.
Okay, that works. So now I'm just going to talk a little bit about what I use Reticulate for at my job as a data scientist at Intermountain. So this year, surprisingly, we've been asked to do COVID projections for the the pandemic that's been going on. And so a lot of times these epidemics and these diseases can be modeled with what's called SIR modeling. So essentially you have certain states of a disease, and this is just the most basic way we can define a disease model. So we have a susceptible, we give the disease phases, and then we move between each phase of the disease. So just starting from a very basic disease principle, we have a susceptible population that moves to an infectious population that eventually will move to a recovered population. So assuming everybody is susceptible, everybody will go through each one of these states, and they'll move from each state at a certain rate. So there's a certain rate that takes, if our infection rate is 2, then for every person in the susceptible population, 2 people will move into the infectious population on a given day. And if our recovery rate, let's say it's 7 days long to recover, then essentially 1/7 of a person will recover every day. So our recovery rate would be 1/7. And so we know that these are the most simplest phases of a disease where we move through from our susceptible to our recovered, and we can actually write these phases of a disease as differential equations to say, so tomorrow's state is going to look like today's state. So tomorrow's susceptible compartment is going to look like today's susceptible compartment multiplied by an infection rate, right? So we have a proportion of the people that are infected, how many people they can affect, and the rate at which they infect those people. This very similarly for tomorrow's infectious state, where we're saying, let's take all the people that moved into the infectious state from the susceptible state, and then we're going to subtract all the people that left the infectious state and moved to the recovered state. And the recovered state is all the people that came from the infectious state to the recovered state. This is just like a very high level view. There's obviously a lot more detail that goes into modeling something like COVID, but this is just kind of like a simple example I just wanted to go through for now. And a lot of times these derivative functions and their solvers are written in Python, just because Python has a lot of packages that can integrate through these states and a lot of stability with those packages. So we know that we can actually get a solution for each state. So we can set up this model in a Pi script. So we'd set it up like we'd set up a normal Pi script. We'd list the packages that we need. So the package we're going to be using is scipy.integrate. We're going to use their ODE solvers to do these things. We'd set up our differential equations in a separate function. So we'd, and here we have the same equations that were from the PowerPoint presentation. We have a beta rate. Then, we have our susceptible compartment, our infectious compartment, and our recovered compartment. And then we would just return each of those compartments on each day. We also have a wrapper function to integrate through each compartment for each day. So I can go through this in a little more detail, but the main thing that I want to say here is that this is, these are Python functions, the Python capabilities, and we want to be able to pass these parameters into our model and then get out an output and use that output in R, because R does have those visualizations that we love. It has the capabilities to do things that Python may not necessarily always have. So here we can source these two model functions. So if we source a script in R, we can see that it will bring in our functions here. So it brought in our SIR function that we defined and our SIR model function. And now we can call that function, since it's in our environment, we can call it just like we would call a R function. So we have our population size, our initial number of susceptible, our initial number of infected and recovered. And we also have those two rates that were described. So we have our infection rate and our recovery rate. So we can use, I should probably run these first. We can use that solver, from Python, and it will give us back a data frame that's actually an R data frame. So if you're calling, even though we set up a pandas function to return from our model, reticulate knows that we probably will want to use it in R, so it already automatically converts it to an R data frame. And then we can plot this, each one of our states. So we can say, okay, at this infectious rate, given our initial parameters, in a population of 3 million, 2 million people will be infected 15 days in, right? Which is obviously a very aggressive approach, but it's just, it gives us the ability to say, to quickly change these parameters and run a new model and get a different visualization out. And also gives us the ability to say, put these parameters into a Shiny app and to make an interactive tool that we can use on the fly to, to adjust for these given pieces. And so, we can even develop this model a little further. So this is kind of the steps that we have taken on our team to say, let's add another compartment here, to try to account for the COVID disease. There's an incubation period. So where you are sick, but you're not infected yet. So, that's about 3 to 5 days. So we can add another compartment for this exposed period or this incubation period. And we can add another derivative equation for that model and another incubation rate for that model. And then we would have a new function, a new script, and we would say, all right, instead of an SIR model, we're going to say this is an SEIR model, and we're going to count for that incubation period. We can add our derivative function here. Just add one more parameter into our model for our initial exposed and the incubation rate. So if the incubation period is 3 days, the incubation rate would be 1/3. And we can source that function, set up our initial values, and then pass pass those parameters to that function, it would output the same way it outputs as a R data frame, and then we can plot it very easily to say, so if we have this exposed period, here's what it would look like. Here are the people that are exposed before they would become infectious and before they recover as well. Which leads us to kind of the last version of the model I wanted to show here, which is a quarantine compartment. So we know there's, with COVID, once you've been exposed to it, once you're infectious, a lot of times if you test positive, you would quarantine for about 14 days. And so you wouldn't get anybody else sick. So, we wanted to model what that would look like, to see if the number of people that are removing themselves from the infectious population, recovering on their own, what that would look like for the overall pandemic curve. So to do that, we'd add another compartment, which would include another derivative function. And then we'd have rates that, that the infectious period, we're going to call it mu. So, if our mu is 50 or 0.5, then 50% of people that were infected would quarantine. So, and then from that quarantine, we'd move into an overall recovery rate as well. So, just kind of like a caveat with these types of models, you just have to be very aware of how people would move in between states and how the rate at which they would move between states. And you have to have a specific rate for each state. That way you can make sure your functions are structured properly and that you're actually getting the correct information that you would need out of that. So I've set up that function as well. So here would be our SEIRQ model where we'd add that quarantine state. So we'd add another quarantine derivative. So that would include another parameter to the function where we'd say here's the initial number of people that are quarantined and the rate at which people quarantine, which is defined by mu. So if we source that into our R code, leave all the other parameters the same and say, let's say 50% of people, of infectious people would quarantine. So the solver runs very quickly. And so that's one of the great things about using Python is that, they've set up a very stable and quick processes for these solvers. So we could see that if half the people are quarantined, then, only half the people are infectious. So we can see this total infectious bump is much smaller than the million we were seeing before, and it would happen much further out. So before we were seeing that bump around 15 days, we could move that out to 55 days. So, we can see that the effects of that quarantine would have in the model, and we would know that, the model was running correctly and that we could model this disease correctly.
So there are a couple of questions that have arisen about this conversion. Like you run the model and then it comes in as an R object that then you can plot or do other things with. So there are a couple of good questions about this. So have you had experiences or do you know about kind of the cost of that conversion from like the Python object to the R object? Like either in computational time, or are there in memory two objects? Like, is it holding the Python version? Like, are there two copies? Or are there costs? How much of a computational cost is there time wise when you're having to move it from Python into R, and then are you ending up with multiple copies of these what could possibly be large objects in Python and R? Do you know?
Yeah.
Or have you had experiences with that yet? Or
I haven't seen instances where both objects were copied in both languages. So normally it would just store it as an R data frame. But I have noticed that as we build on these compartments, we can start adding a compartment for hospitalizations, for ICU, for deaths. And so as we start building more and more of these compartments, I've noticed that If we try to do these derivative functions in R, it's a little bit slower than doing these derivative functions in Python. So I think what you lose in trying to convert it back, you actually gain in as your models get more and more complex.
So you haven't noticed in the like real life applications you have used the problems of like passing data back and forth between Python and R have not been problems you have run into or noticed.
No,
You've
not
noticed
for,
been like, oh, it's taking a long time to do the differential equations in R is like the problems you have noticed.
right.
Okay.
That's definitely the larger problem than the data and the computational power itself.
Yeah. Yeah. Do you, so, can you comment on like the order of projects you have used reticulate for, like on the order of size and like whatever comes to mind? How big of data sets have you used reticulate for in terms of like passing data back and forth, like a number of
Um,
rows or
I've never used,
observations?
yeah, anything too large, like nothing more than a few thousand rows.
Okay.
Um, I have asked Reticulate to do like some uh, web scraping processes and API calls as well, and so it does work seamlessly with even those functionalities.
Yeah.
But I don't pass too much data through to one function to another.
Yeah. 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 So my experience with reticulate has mostly been on the modeling side. So like doing say like pre-processing in R and then passing it through to reticulate to say like a Keras model. And that can be significant amount of data. And again, that's a situation where the amount of time the model takes is long compared to the amount of time that any kind of data handoff takes. And so it's not a problem that you really notice. But this would be something, it's probably something that depends a lot on the domain that you're working in. There
Yeah,
are some more
absolutely.
questions to kind of talk about. I don't know if you want to finish anything else off before we kind of dive into those.
Oh, no, I think we should dive into the
Okay.
questions.
All right. Great. So another interesting one that came up was someone mentioned Dask. And I think that's an interesting example because as far as I know, I think that's an example of when reticulate actually might not work very well. And I thought maybe we could talk about maybe examples where you're like, oh, I would not try to use reticulate, an example like this, like here are these things where it has worked quite well, and then maybe either things you've tried where it hasn't, or things where you wouldn't. So Dask parallelizes, maybe someone can state this better than me, I haven't used it a lot, but like will break apart um data manipulation jobs and will like parallelize
Okay.
it for you. Is there a better way to say that? Or
I have not used
okay,
Dask,
okay.
so I probably wouldn't say it any better.
Yeah, so it does it helps it parallelizes things that you might do with um pandas or like dplyr if you're an R
Okay.
user. So it like will like parallelize that. And so my gut is that is something that actually would not work that well because you're trying to break things apart and then send it out to workers and then try to get it back. And so you're going to be trying to like pass data back and forth in a fair, like, I bet that doesn't work very well right now. And I actually just found an open issue on the Dask. Here, I'll put it in the chat.
Okay.
Oh, whoops. Let me try that again. Let me put this in the chat here. So there's like an open issue on Dask, like, hey, can we get this to work better with Reticulate? And apparently it's not working very well right now because of this issue of like going out, like parallelizing, going out to issues and coming back in. Anyway, I think it's interesting to think about like this. This is an example of when it's not currently working yet very well because of me, like mainly the parallel issue, I think. And so
Yeah.
Gabriella, I was wondering, you've listed quite a lot of things where it's like, oh yeah, it worked great for this, it worked great for this, it worked great for this. Are there things that are that you have tried that didn't work,
Um,
or that you decided not to try because you're like, oh gosh, that will be too much of a hassle? Or
yeah, certainly there's a lot of things, and I really only use reticulate if there's something very specific I need from R, like putting something into our EDW, or trying to manipulate the data or create a Shiny app in a certain way. So I think you would only really try to leverage it for those specific use cases when you know you're more comfortable showing the output or the deliverable in R. Um, I've tried to use it for API calls, and that definitely doesn't work as well when you're trying to do like an authentication and do like a token and key pass off. And so that one doesn't work as well. You're probably better off using just Python or the source R, because I know R has an API call as well. I imagine doing something like a neural net, and it wouldn't be good practice either. So I think if, like kind of what we were talking about before, if Python is very good at certain things, you probably should just do it like entirely in Python.
nice. So speaking of Shiny apps, there was a question about like handling user inputs. And I know I have seen people who have like Shiny apps that have reticulate in them, and they like, and that is a little mind blowing actually, to like take user input through R and then maybe use that. Have you built anything like that, or can you speak to how that kind of thing would be handled? Or do you
Yeah,
know?
I have
Okay,
I have
okay.
built something like that. So I've built an interactive tool for these functions. We can change our parameters on the fly, and and we can have different users go through what if scenarios. And I think it definitely works very seamlessly, and it works in the same way because you can just take an input, save it as a variable, and then pass that variable as a parameter into any function, whether that be reticulate or a function in R already.
Yeah, nice. You showed using R in just like an R script here. Um, Somebody asked about using both Python and R in R Markdown. And
Oh
that
yeah.
is something actually that I have done, and I wonder um, if you have either tried it or thought it was, if you liked it or didn't like it, or haven't had chance to use it, or
Yeah.
any
I have
thoughts.
tried it before, because I know you can make like it's the chunks of code different languages as well. I found that to be just a little bit slower, so I think I'm just more comfortable doing it entirely in a script than a notebook. But I think if you're trying to make an R notebook, it's definitely possible to do.
Yeah. Yeah, that I think most of my like mixing of the two has happened in our Markdown, because I in my life I have tended to do so much reporting and so much
Right.
like document generation, that has been like, that's when I have done it. Uh and like, yeah, being able to have like, here's a Python chunk, here's an R chunk, and that the objects that you create in one are available in the other, is what was pretty mind blowing to me when I first did it. And that I think it's a pretty nice workflow if you're someone
Oh,
whose
for sure.
main goals are like report generation and whatnot. I like that a
Yeah.
lot.
R is definitely very good at automatically converting the things you need to convert as well. So that's always nice.
Yeah, yeah. Let me see if there are other questions here. So if you have anything else that you want to put in as a question, um, go ahead. And actually, if you want to verbalize your question, certainly feel free to, you can do the little hand raisy thing in Zoom and we can like unmute you. Okay, someone did say like, someone here, Joe, said that he's like, his first instinct, if he had a problem like this, might be to have a Python script and use it to like just generate all the results, say maybe like solve all the differential equations, do all the solving, write it to disk, and
Yeah.
then read it in with R, say for a Shiny app, and to approach this problem that way. So what would you say are like the pros and cons of using reticulate to say create the Shiny app or whatever, um, it, to do that instead of taking that approach of like just really separating the two?
I think it definitely would depend on your use case. So if you wanted to do something that took in your parameters more automatically, or you knew your parameters were going to come in from R, I think you'd want to use reticulate so you could update those call functions, and not have to write, uh, some sort of CSV output of all your projections, for every single use case. So I think, that's nice. And once we start getting more and more complex functions, you can see how these parameters just start to add up, and it's definitely harder to track each parameter and harder to find out, which iteration of parameter and iteration of model someone may want to view. So like in the model that we're using, we have maybe like 20 or 30 parameters for our function, and it's millions of iterations of what if scenarios. So I think it would just depend on how complex, your use case is going to be.
Nice. So there's a question about learning more. So first of all, I don't think I should have asked you this offline first. We do have a GitHub repo where we like keep some things from some of our things, and so if Gabriella is willing to share, we would love to maybe have any of the materials you prepared to that people could look at afterwards if you're up for it, Gabriella.
Oh,
But
absolutely.
awesome. Thank you. Should have asked you that beforehand and
Yeah,
not put you on the spot. So
of
maybe you
course.
can look for that, like on our GitHub repo for anything here. But I was wondering, maybe for you, Gabrielle, like maybe especially someone who had the specific background you did, what were some resources? So people were asking like like hey, where could I go to learn more about, like what were resources that you found helpful for learning about reticulate, how to use it, like how to move back and forth between R and Python, like maybe avoiding gotchas. Like what did you like for learning more?
Um, there's no very specific place that I went to find that information. It was more just whatever the function documentation was, or if there was an example out there, like in a Medium article or something like that. But I think the biggest thing is to just kind of try it out and see how far you can actually push these functions and these capabilities. And then I think that's really the way that I learned most, is just saying, what, this might not be the best reason or best use case for it, but I want to try it out and see if we can get something functional out of this.
Yeah, yeah. Nice. So someone says they're like a Python newbie, and like is reticulate like a good way to learn Python? And actually, so my knowledge is much deeper in R than in Python. I actually learned Python first, but it's much shallow. My knowledge is much shallower. And I don't know if you're like an absolute newbie, but if you're someone who can like mess around a little bit with Python, reticulate opening up the world of Python to like you as an R practitioner, like really has like my experience is it has really been like, oh, now I have this just motivation, opportunity, reason to like kind of increase my skill in Python and my exposure to like really great tools for the areas I'm interested in. So I don't know if it's like if you don't know if it's like you're just starting with Python to be the way to go. But if you just know a little bit, I feel like it's like, oh wow, I can just take bits and pieces and move forward. I don't know. That's my thought on it.
Yeah, I would agree. I think it's a good place to start learning. And like I said, it's just kind of any problem you have, it's just fun to dive into to see which ways you can solve it. And so it's definitely a safer way to learn.
Yeah, yeah. All right. I know we're coming up on the hour. Gabriella, any final thoughts?
Um, nothing else for me. If anyone has any questions, please feel free to reach out on LinkedIn or through the meetup as well. And I'd be more than happy to post this code to the GitHub repository.
Awesome. Well, we will get that. So I want to thank you all so much for coming. We will hope to see you next month in early December for our meeting where we talk about natural language processing and stop words and model defaults. And I will just drop the link one more time for our lightning talks that will be in early in early February, and that the form is there. And I will be sending that out via email as well to the meetup group because we would love to hear from, folks who are in our community about things that they have learned and things that they are interested in. So maybe we can do some silent hand clapping for Gabriella, and we will see you next time.
Awesome. Thank you.
Thank you so much.